Good morning, everybody. I decided to make a video to help you learn 3.5 because unfortunately I have a high fever and I'm stuck at home today. So I'll take you through it. The good news is that you can stop and rewind or re-listen to this as you go. Talk to the people in your group. Make sure you're asking questions as you go along if you're confused, because a lot of people in this classroom understand this information and they can teach you. So please take the time, and then don't forget you have the other geometry teachers that you can go see should you need a little bit of extra help if you have some confusion. Okay, so this is our last section we're going to cover in Chapter 3. There is one more section, but we're not going to do it. We're going to stop at 3.5. And then on Monday, when I see you again, we're going to have a short quiz at the beginning on 3.4 and 3.5 so I can see how you're doing with that information. I'll try to grade it as quickly as I can and get it back to you. You can come see me maybe in the afternoon, Tuesday, to get it back so you can review it before your test on Wednesday. I know it's not ideal, but I just want you to get some feedback on whether or not you really do understand 3.4 and 3.5. And we'll try to review all day Monday and answer questions then as well. Okay, so our last topic is about polygons. So, in angles of a polygon. So we're trying to recognize and name convex polygons and regular polygons. We are going to find the measures of interior angles and exterior angles of convex polygons. So you'll have all of that done before the end of this lesson. But you will need to do that homework and repeat the process because, again, there's lots of information to learn in this chapter, lots of information to memorize, to understand, not only the theorems and postulates, but the definitions, and then all of these formulas you're going to learn today. So what is a polygon? A polygon is a closed figure in a plane formed by connecting line segments, endpoint to endpoint, with each segment intersecting exactly two others. Each line segment is called a side, and each endpoint where the sides meet is called a vertex. Okay, so we have sides and we have vertex, or vertices, plural form. Then we're going to talk about diagonals. A diagonal in a polygon is a segment that connects two non-consecutive sides, right? So two non-consecutive vertices might be even better. So two non-consecutive vertices. So down here, put a P on the shapes that are polygons. So go ahead and look those over. You must have sides, and you must have vertices, and you must have segments, line segments. Right, so that eliminates any kind of curve, right? We must have straight line segments. So that means this one is no good, this one's no good, this one's no good, this one's no good. Okay, so here it's a closed figure, okay? This is not a closed figure, so that one's no good. And so this one I would say is a polygon, this one is a polygon, this one is a polygon, this one is a polygon. What about this last one? So this last one is not a polygon because it says each endpoint to endpoint is where the line segments meet, with each segment intersecting exactly two others. So here, this is intersecting more than that, so that doesn't work. So this is not a polygon. Okay? So these are not polygons. Okay, now we're going to narrow down that definition of polygon to a convex polygon. So what is a convex polygon? It's a polygon such that no line containing the side of the polygon contains a point in the interior of the polygon. So you can't have anything on the interior of the polygon. Maybe that's difficult to understand, so you can try this. A convex polygon also has all of its diagonals on the interior. And again, how do you connect a diagonal? A diagonal is a polygon. It's a segment, a diagonal in a polygon, it's a segment that connects two non-consecutive vertices. So here, if I do this one, well, these are consecutive vertices, so one of my diagonals is from here to here. So non-consecutive, here, these are non-consecutive, right? I have this one, these are consecutive, but the other three are non-consecutive to this point. From this point, these are the only consecutive ones, the ones side by side. So these are the diagonals from that point. And from this point, these are the consecutive vertices. So I would connect here and here. From this point, here are my consecutive vertices, so I connect here, 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 and this one's already had all of its connections made. So is every single diagonal on the interior in this one? Yes, it is. So this diagonal is also a convex diagonal. Okay, how about this trapezoid, or this quadrilateral four-sided figure? So let's do our diagonals. Non-consecutive sides. These are consecutive right here. I don't have to lift up, or I can continue to that vertex without going through the interior. Here's the other diagonal. There's only two diagonals in this shape. They're both on the inside, so this is also convex. Look at this one. If I start here, this is non-consecutive, 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 non-consecutive. Those are all on the inside. But then we start here. Here's consecutive and here's consecutive. So non-consecutive would go here to here, here to here, here to here, here to here. So here, this is on the outside. So this is not convex. And finally, this one over here. Well, right here is a diagonal. Oh, no, that's not diagonal, sorry. This is the only diagonal here, right? Because these are consecutive sides. And that's on the outside. Therefore, this is non-convex. So we only have two convex polygons. They are these top left and top right shapes. Okay, let's talk about the names of the polygons. So yes, you need to know all these different names. So if we tell you what a pentagon is, you need to know that's a five-sided figure if we use the word pentagon in a problem. So a three-sided figure is called a triangle. A four-sided figure is called a quadrilateral. And then we have a lot of specific quadrilaterals we'll study later. A five-sided figure is called a pentagon. A six-sided figure is called a hexagon. If you're curious about a seven-sided figure, I guess you could look it up, but I'll tell you it's a heptagon. Probably not one that's very common or will make you memorize. 8 sides is an octagon. Think of a stop sign. 10 sides is a decagon. 9 sides is a nonagon, if you want to know, but you're not responsible for knowing that one. 12 sides is a dodecagon. And n sides is just an n-gon. Okay, so you need to review those on your own. So last class we learned the sum of the angle of the measures in a triangle always equal, hopefully this is coming to you right away, 180 degrees. Right, so we know that all the angles in a triangle add up to 180 degrees. There's 3 of them. What is the sum of the measures of the angles in a quadrilateral, a pentagon, a hexagon, any kind of polygon? Well, let's find out. So we're going to do a little activity to discover that. If you know already, then I guess you can move on. If you don't know, then you can watch through this. So draw a quadrilateral. So you can draw any four-sided figure, right? A quadrilateral is a four-sided figure. Get your ruler, or you can freehand draw. So here's my quadrilateral. If I'm going to label it A, B, C, D, I need to go in order around the vertices. No matter which vertex you start at, you have to go in order all the way around. You can't skip. So it has to be A, then B, then C, then D. Or if I made it like this, I could say A, B, C, D. Doesn't matter clockwise, counterclockwise, they just need to be consecutive, one after the other, in this order. Okay, let's connect diagonal AC. Okay, whatever your diagram looks like, there's diagonal AC. How many triangles do you see? Well, here's 1, here's 2. I see 2 triangles in my quadrilateral. Well, what is the total measure of interior angles of a triangle? We just said it's 180 degrees. Therefore, if this one is 180 degrees, and this triangle is a total of 180 degrees, and I have 2 triangles, then all 4 of these angles in here must be what? That's 180 times 2, because there's 2 triangles, so that's 360 degrees. So now you can just fill that in the chart down here. A triangle is 180 degrees, a quadrilateral has 2 triangles formed, which is 360 degrees. A pentagon. We are going to do this with a pentagon, hexagon, a heptagon, an octagon, and draw as many diagonals as possible but no diagonal should intersect. So notice I only had the one diagonal, not both up here. So here, if I start here, I'm going to draw a diagonal here and a diagonal here. So I have 1, 2, 3 triangles, and then I multiply 3 times 180, and I get 540. Right, and do the same thing with all the other shapes. So if you want to pause now, go ahead and try it on your own and find out the pattern. Okay, if you unpaused, you should find that there are 4 triangles in a 6-sided figure. So we're going to multiply 4 times 180, right? And so we would get 720. In a 7-sided figure, all my diagonals that do not intersect. So I have 1, 2, 3, 4, 5 triangles. So this is the number of triangles formed. This is the number of sides in the original polygon. This is how much their interior angles add up to, what the total sum is. So this would be 5 times 180, which is 900 degrees. And then my 8-sided figure. So I have 1, 2, 3, 4, 5, 6 triangles. So that's 6 times 180, which is 1,080 degrees. So now, can you go on? Can you deduce, or what do you think, or induct? What do you think is going to happen? Inductive reasoning. What do you think is going to happen? So look at the relationship. There's 2 less triangles than there are sides. So there's 2 less triangles than there are sides. So this is going to be 7 times 180, which is 1,260. Okay, so that leads us to our general formula. Well, what happens if we have an n-sided polygon? We don't know how many sides there are. It could be any. So what's the general format? How do these 2 numbers relate to each other? So this number in the triangles formed is 2 less than the number of sides. So how do I write 2 less than the number of sides here? So that's just going to be the number of sides minus 2. And then how do I calculate the angle sum? Well, what did I do? I took those number of triangles and multiplied it by 180. So I take the number of triangles and I multiplied it by 180. Or usually algebraically we would write it as 180 times n minus 2. So did you discover a formula for an n-gon? Yes, you did. Let's complete the theorem below. It says the sum of the measures of the angles of a convex polygon with n sides is, so to find the sum of all of the angles inside a convex polygon, we would use this formula right here. 180 degrees, that's the degrees of a triangle, times the number of triangles in that shape. And there is n minus 2 triangles compared to its sides. So now can we find out how many degrees are in a 32-gon shape? Sure, well that's going to make 30 triangles. So that's 30 times 180. So you should get 5,400 degrees inside a 32-sided figure. So go ahead and pause and try to answer this last question. Okay, if you paused, there's a couple of keywords here. One of the keywords is you have a pentagon. It says 4 of the angles of a pentagon. Okay, well, pentagon, you look in this chart up above, the pentagon is a 5-sided figure. Oh, sorry, that's on the previous page. My fault. Pentagon is a 5-sided figure, right? So we know that the pentagon has 5 sides. So in my 5-sided figure, I only have 4 angles. They are 40 and 80 and 115 and 165. I do not know the 5th, but I have to find the measure of the 5th. Well, how can I do that? Well, if you look at this chart, every 5-sided figure, every pentagon is going to have a total measure of 540 degrees. So I'm going to add this up and then subtract it from 540 to find x. So I get 400 plus x equals 540. Therefore, the 5th angle is 140 degrees because 540 minus 400 is 140. Okay, video 2 is next for the last 2 pages.